My presentation will be held in English, for all the foreign speakers, and maybe if anyone else needs headphones, this is the time. I'm going to present the grouting works that we did in tunnel T2. Yeah, maybe I will switch to this one, maybe better. Is it working? Yeah, okay. That we did in the tunnel T2 on the second railway track, Divača Koper. We prepared this paper together with my co-authors, Divača and Aydın Baker. We all come from Yap Marchesi, which is one of the contractors working on this project. I will present two different injection approaches and provide explanations why we chose them in this tunnel. Presentation will be as follows. First, I will give a brief project description and the grouting location description. After, I will talk about geological and hydrological conditions in the area. After, I will explain a little bit about grouting methodology. And in the end, I will talk about conclusions. The second railway track, Divača Koper, is a 27-kilometer long railway line that runs from Divača to Koper and is divided into two lots. Our company is involved in construction of 6 out of 7 tunnels and 1 viaduct. And the grouting works were done in the grouting works that I will present were done in the tunnel T2, also named Bika, in both main and service tube. We can see where this tunnel is. And the grouting works were done in 2 almost parallel locations, approximately 200 meters from the Koper portal area, which is marked with the Tunnel T2 runs through a region in Slovenia called karst, where the dominated rock is limestone, but even though both tubes of tunnel T2 start and end in flysch formations, this limestone is interspersed with karstic phenomena, and they can be filled with water, which has the capacity to rise and create pressures over 14 bars in a short period of time. Additionally, this tunnel also runs through an aquifer, which is responsible for coastal water supply. So in the design phase, strict hydrogeological criterion was set for the water withdrawal from this tunnel to 10 liters per minute per 100 meter of the tunnel. In this geological profile, we can see the grouting location in the service and main tube of tunnel T2, which is marked in red. And the first grouting section was defined in the service tube of the tunnel after we encountered a karstic phenomenon, cave 24, which can be seen here on the right side. And this mapped geological profile is taken from this red colored section on the left-hand side. In the service tube, polyurethane grout was chosen as the material of grouting. This was governed by the karstic phenomena, which was filled with running water. We had a lot of bigger local inflows, and also we installed drainage pipes in order to safely continue with excavation after this cave was encountered. We used a 2-component polyurethane, which has the following benefits. It has a fast reaction time, especially compared to cementitious grouts. It is resistant to higher water pressures, and it has an expansion factor. And also, and very important, is that it has a certificate for drinking water, so if it comes in contact with drinking water, it doesn't pollute it. Before the application procedure started, we marked all the injection points and referenced them. We can see on the left side the top view and the cross section where we also present the cave system. So we had to be very careful. Here is a representation of one point, and in this manner we marked all of the injection points. And we had to be very careful because we couldn't interfere with the cave system. In any case, we should never block the natural water flow with it because it would be very dangerous. We could rise the pressures of the water, and it could mean additional pressures to the primary lining of the tunnel. Injection was done by targeting water inflows in ascending change direction in order to push the water into one direction and not create water pockets in between the injection boreholes.
Pardon, se upravičujem.
So this is how injection looked like, and the drilling was done with a hand drilling machine. We had one additional condition: if there was no water coming from the borehole, we didn't inject. With this, we wanted to secure that the injection boreholes had a connection with the discontinuities and cave system in the back. The borehole lengths were shorter, and with this we wanted to assure that we will create a barrier that would stop water as close as to the behind the primary lining as possible and not interfere with the cave system deeper. And the maximum injection pressure was set according to the maximum pressure of water, which was 2 bar, defined by supervising hydrologists. And injection times, which are in generally defined with running water. So once the water is stopped, you stop injecting. But in this case, because we were working so close to the cave, we set the injection times to 5 minutes in the most critical cross sections. And after 5 minutes of injection, we stopped and we were monitoring the manometer, which was installed on the drainage pipes inside the cave system, so that we knew that we didn't affect the natural water flow. All of this water in the service tube and in the cave system also affected the water ingress in the main tube of the tunnel, where cement grout was chosen, and there were a lot of smaller water inflows. And the tunnel was designed as the drain tunnel profile. And again, we had to fulfill the hydrogeological criterion that I mentioned before. So not only for the excavation and construction part of the phase of the tunnel, but also for the future use of the tunnel. The grout mix was prepared in the laboratory. It fulfilled all the design criteria, and it was confirmed on site with Lujon tests. And with this Lujon test, we proved that the conductivity of the rock mass went from medium to very low after we did this test grouting injection works. Our aim was to create an impermeable ring around the tunnel top heading. Before the application procedure started, we marked all the water inflows in order to monitor them after the grouting works. And injection was done according to the design injection pattern from the executive drawings and in ascending change direction. Drilling, in this case, was done with epirock drilling machine because the borehole length was designed at 4 meters. They were 1.5 meters apart. And injection pressures and injection times were dependent on the tightness of the discontinuous in the rock mass. To conclude, we were successful in both tunnel tubes. We managed to reduce the water inflows in both tubes under the hydrogeological criterion set. And in main tube, therefore, there was no reason for an undrained tunnel profile. And in service tube, we created safe in terms of drier working conditions in the tube. And we didn't affect the cave 24 and its natural water flow. And with this supply of the drinking water for the coastal area. And I would like to emphasize that the choice of grout and grouting application should be governed by the geological and hydrological conditions in the area, and that each of the grouting procedure has its own benefits, and I mentioned these, the ones that I have talked before already. So, thank you for your attention.
Thank you, Katarina. Are there any questions from the audience? Yes? Please, Wolfgang.
You did inject also polyurethane, and
Yes.
you did have very shallow injection hole.
Yes.
Polyurethane in contact with water expands and foams and builds up some pressure. How did you deal with this pressure so close to the lining?
Yeah, we went behind the lining, so we went behind the lining, and our injection times were shorter. So with this, we tried to minimize the pressure on the lining.
Did you establish any control of pressure or deformation or not at all, or just volume
No.
controlled?
No, we didn't.
Any other questions from the audience? Okay. Thank you, Katarina. We have to stick to the timeline. Thank you.